Okay, welcome back. I want to talk about section P2. And section P, or chapter P, is really still preparation for calculus. We haven't gotten there yet. So we're still working on preparing. And now I want to talk about lines, linear models. We talked about graphs, plots, plotting ordered pairs, looking for intercepts, looking for symmetry, and being able to plot that so that we can visually see the graph and know the difference between a quadratic function and a linear function. And we can really see it if you plot it. Now what I'd like to do is talk about lines in particular, and I want to focus in on the slope of a line. I want to focus in, talk about the slope of a line, what the definition is. If you were to draw a line, the slope of this line, which is really like the tilt of this line, is calculated by simply grabbing 2 points. And we'll label this point x2, y2. We'll label this point x1, y1. And we're going to call the slope m, and that is calculated as rise divided by run. Now, in this picture is a triangle. If I draw a horizontal line here, and if I draw a vertical line here, you can see the rise and the run. The rise is right here, and the run is right here. Now, the run would be the difference between the two x values. See, x1, x2, because the run is also down here, so you just subtract these two. The rise is here. And if you were to extend that across, that's just simply the difference between the y values. So I would calculate the rise as y2 minus y1. I would calculate the run as x2 minus x1. So rise over run is definitely the way to compute slope. So let me give you an example, and let's compute some slopes. First example will be, I'll give you 2 ordered pairs that are on my line. So let's go ahead and draw, again, a line. We'll put it over here this time. And let's do this. 1, 2, 3, 4, 5. Make that 1, 2, 3. So I'm going to give you 2 points. Let's do this point here and maybe this point over here. It doesn't matter which 2 points you use. So 1, 2, 3, 4, and 5, and -1, and -2. So this point here, x1, y1, is 1, -1. This point up here is looking to be 3, 1, x and y. Let's calculate the slope. Slope is rise over run. That is the difference of my y values divided by the difference of my x values. So labeling this as x2, y2, and x1, y1, y2 would be 1 minus y1 is -1, so be careful on that one, double negative. x2 is 3 minus x1 is 1, so what's my slope? My slope is 1 plus 1 is 2. 3 minus 1 is 2. I got a line of slope 1 right here. That's slope 1. Note that it's positive. And when the slope is positive, a positive slope, your graph goes up. But when it's read from left to right. And naturally, this graph definitely goes up. Let's look at a graph that has a negative slope. So let's try this one more time. And let's draw xy plane. And let's put some points out there. So let's put 1, 2, how about we'll put a point here, and then 1, 2, 3. I'll tell you what, we're going to give you the intercepts. On this curve, you don't get an equation. You get 2 intercepts, the x-intercept and the y-intercept. So let's take a look at that. Okay, draw this graph, and it is a line, and the line goes down. That's going to give me a negative slope. If I were to label this point, that's 0, 2, which is x1, y1. This is 3, 0, which is x2, y2. And, of course, slope, as usual, is rise over run. And that's y2 minus y1 over x2 minus x1. So let's go ahead and compute it. And let's see if it makes sense. Let's see if it turns out to be negative. So y2 is 0 minus y1 is 2. x2 is 3 minus x1 is 0. What do we get? Rise over run, negative 2/3. Now what that says is that if and let's label this, rise and run. What if you were to run over 3 units from any point on this graph? Run over 3 units. 1, 2, 3. Well, now it says rise by negative 2, meaning fall by 2. Fall 1 and 2. And you land on a solution point. So it truly is rise over run, and that is your slope. Now I want to discuss the equation of a line. So far I've just plotted coordinates. 2 points determine a line. You connect the dots, you've got a line. But what is the equation that describes every point on the line? Not just the intercepts, but every single point on the graph. There are different forms of the equation. I'm going to start with the first form, which is slope-intercept form. Slope-intercept form for the equation of a line looks like this. It's probably the most common form we'll use in this class, y equals mx plus b. This is the same m as before. It's the slope. This is the y-intercept. And if you have the equation of a line in slope-intercept form, this is pretty easy to graph. So here's the equation of a line. We know from before that an equation, a relationship, describes a graph. And a graph is a set of ordered pairs. It's a table. It's the plot. The graph is all of the solution points. So what are the points that make the left and right side of this equation equal? Well, we could do it the old-fashioned way. We could make a table. We could list a bunch of ordered pairs. But why not take advantage of slope-intercept form? So the y-intercept is 3. Now remember, a y-intercept lives along the y-axis. So if it's living along the y-axis, it has an x value of 0. So right away we have an ordered pair that represents the y-intercept. Slope is right here. That's negative 2. Remember, that matches up with m being negative 2. Notice the x and the y don't go anywhere. So x and y should stay in the equation, but slope is negative 2. I think the best way to write your slopes are as fractions. So if it's not a fraction, make it a fraction. Divide by 1. So this is my rise, and this is my run. And you know what slope really is? Slope is a set of instructions. It says this is the way to get from one point to any other point on your line. So what we're going to do is we're going to graph or plot the y-intercept first, and then we'll just use the slope to get a second point. We use the slope again to get a third point, etc. As many points as you'd like, without doing any calculations at all. So let's go ahead and draw an xy plane here and graph our first line just using slope-intercept form. So here's x and y. We'll mark off some labels here on the x-axis. Let's go backwards a little bit. -1, -2, -3, -4. And of course, we need some tick marks in the y direction too. 1, 2, 3, 4, 5, and down, -1, -2, -3. Now, the first thing you're going to do is graph one point that you definitely know is on the line, which is 0, 1, 2, 3. That's right here. So there's your y-intercept right there. Y-intercept, 0, 3. And now do not plot -2 or 1. Use the slope as a set of instructions to get to another point. I don't care what order you do this in, by the way. I like to run first, though. So let me run over 1 and fall by 2 units. Place yourself a point that is on the line. Let's do it again. Run over 1 and fall by 2 units. 1, 2. Place another point right there. Now, like I said, the order doesn't matter to me, so if you want, you can fall by 2 units, 1, 2, and then run over by 1. And generally, we like to run in the positive direction. There, run over by 1. Notice that no matter how I did that, they all line up. So we definitely have the equation of a line, and this is the best way, I think, to graph it given that particular form. So there it is. Really no calculations other than slope. We don't really need to use the equation of the line and plug x's and get y's back. We don't need to do that. And yet on the plot are all of the solution points, including this one. What is that point? Let's see. According to this picture, that's 3, -3, and it's supposed to be a solution point. So it better make the original equation true. The original equation is y equals -2x plus 3. Let's check it out. X goes here, y goes there. So is it true that -3 is equal to -2 times 3 plus 3 is -3 equal to -6 plus 3? And the answer is yes. So that's why it is a solution point, because it satisfies the original equation. Okay. So that's the equation of a line in point-slope form. What about the equation of a line in some of these other forms? We have another form referred to as point-slope form. If I were to take the slope equation, now another way to discern between 2 points is to label one point x comma y, or make that x1, y1. And let's make the other point over here, instead of x2, y2, just make it xy. We can definitely tell the difference between these 2 points. What if I were to, well, cross-multiply here to here? I'm allowed to do that. So this times 1 is y minus y1 equals m times x minus x1, and we've literally just discovered point-slope form. All right, point-slope form, where do we use point-slope form? Well, let me give you an example. Let's say I gave you a point, 2, 3, comma, 1, 2, 3, 4. 3, comma 4 goes right here, okay? Label that point as x1, y1. So there's your point. And let's say that, well, you know how many lines go through that point? An infinite number of lines. There's one, there's one, there's just a multitude of lines. They all go through that point. Which one do I mean? I mean the line that has slope equaling, how about -2? Or let's make it more interesting, -3. -3 is -3 over 1. There's your rise. Here's your run. So let's do it. Let's run over 1 unit and fall by 3 units. 1, 2, and 3, and place a point. That would be right about there. Okay, so run over 1, fall by 3. Let's do it again. Let's run over 1 unit and fall 1, 2, 3 units. Right there. There's no question there's a line out there, but what is the equation of this line? Okay, so let's find out what the equation is. One of the difficulties of this line is the y-intercept is so high up that I can't really determine what it is just yet. But isn't it true that you're given a point? So you have a point. That's on the line. You have a slope. So why not use point-slope form? Now, to use point-slope form, leave the x and the y alone. Don't touch those because you know that for the equation of a line, you need an x and a y anyway, so leave those alone. But why don't you plug in for your slope and plug in for your point? So it would be y minus y1 equals m slope, -3, x minus x1. I don't really want you to leave it in point-slope form. Let's put it back into slope-intercept form. And the way to do that is to run your distributive law first, and then move that 4 over. This form is a little bit better in terms of if you wanted to graph it later. But notice you got your slope back. It's still -3. And we learned something. We learned that the y-intercept is 13. And that does make sense when you look at this picture. It's going way, way up this y-axis and would ultimately touch it at 13. So when you're given a point and you're given a slope, your best form is slope-intercept form. And then you can find the equation of the line. I would then translate that into slope-intercept form. So point-slope form, put your point in your slope in, and then translate to slope-intercept form. Okay. What I'd like to do is proceed. And I'd like to look at one more form of the equation of the line. That's a general form. Now, general form is definitely my least favorite form. The reason it's my least favorite form is because there's no real good information in there. I can't tell you what the slope is, positive or negative. I can't tell you the y-intercept, the x-intercept. Can't really tell you much of anything. But general form is a form that's used, and it looks like this. ax plus by plus c equals 0. Now, any equation of any line can be written in this form. And if you look at it, everything is piled up on the left side. And there's a requirement. A, B, and C should be integers. And A should be greater than 0. Those are the two requirements we have for general form. Now, there is one strong benefit to general form, and that is you can find the x-intercept and the y-intercept very rapidly. And let me show you how. So let me give you an example in general form. How about we do 2x plus 3y minus 6 equals 0. That is a line because the powers of x and y are power 1. But what's the x-intercept and the y-intercept? Well, you know how to find a y-intercept, right? You set x to 0. Now, before we do that, guys, let's move this 6 over. It's a little more comfortable to do it that way. Okay. Now, how quickly can you set x to 0 when it's in this form? That quickly. Just cover it up. Y equals 2. The y-intercept is 2. So that's how easy it is to get an x or y-intercept. You just simply cover the other one up. But let's do it formally here. If I set x equal to 0, I get 2 times 0, 3y equals 6. So yeah, I basically get 3y equals 6, and I get y equals 2. So the ordered pair would be 0 and 2. Now, if I want the x-intercept, remember we set y equal to 0, the other variable. And how quickly is it for you to set y equal to 0? It's pretty much that quick. Just cover it up. X equals 3. Done. Let's do it more formally, though. 2x plus 3 times 0 is equal to 6. So basically 2x equals 6 divided by 2. Yep, x equals 3. And the ordered pair would be 3, 0. So how quickly can we graph this particular line? This quickly. We draw an we draw a Cartesian plane. We mark off 1, 2, 3 for our x-intercept. We mark off 1, 2 for our y-intercept. And we simply connect the two dots. So there is a benefit to general form, and that is you can find the x and y intercepts very quickly. Let me show you how to translate something from one form to the other. Let's translate from slope-intercept form into this general form. So if I were to give you something like this, y equals negative 2/3 x plus, let's say, how about 3/4? Let's not make it a very pretty y-intercept. How do we get that into general form? Well, the first thing you probably remember from general form is that everything is on the left side. Take a look again. It's all on the left equals 0. So what we're going to do is move everything over. Let's add 2/3 x. Let's subtract 3/4. Let's add 2/3 x. Let's subtract 3/4. And this is what I end up with. I end up with, I like the x first, 2/3 x plus my y minus 3/4 is equal to 0. So we're almost there. But general form, you're not supposed to have fractions. They're supposed to be integer coefficients and an integer constant. So let's find the lowest common denominator. Lowest common denominator here is 12. I mean, 3 times 4. You get 12 for the LCD on this one. So how do you clear out these fractions? Well, if it's an equation, you're in luck because you can do whatever you want as long as you do it to both sides. And the best way to clear out those fractions is to simply multiply by your LCD 12. So if you do that, here's what you get. 24/3 is 8. The 12 reaches over and you get 12. And then you get 12 times 3 is 36 over 4. You get 9. And right there is general form. So giving you a good technique for obtaining the equation of a line in general form and also solving for those intercepts if you need them. Now what would you do if this was a minus 8x? Well, you've got two solutions to that. One is you can move all the terms to the other side, and even easier than that, multiply both sides by minus 1. Now the last thing I want to leave you with in this video is I want to talk about parallel and perpendicular lines. Parallel and perpendicular lines. Two lines are parallel when they share the same slope. So here's a couple of parallel lines on this graph. One here and one here. They will not intersect. So this has slope m1, this has slope m2, and I think it's pretty clear that slopes are equal to each other. That's parallel lines. How about perpendicular lines? Over here, draw another xy plane, and I'll place one line here, and let's find a perpendicular line. There's a bunch of them, but here's one, right here. Now, think about the slope relationship. If this is slope 1 and slope 2, the first thing you could say right out of the gate for perpendicular lines is that they're opposite in sign. So this is a positive slope and a negative slope. There's no question that they're opposite in sign. So let's say you were trying to calculate m2. You know that it has to be the opposite of m1. It has to do something with m1. It has to be the opposite. Now the reason why I put m1 down there is because it's not just negative m1. It's the negative reciprocal of m1. Don't forget to do both. Negative reciprocal. Now, I finished with a problem. The problem is I'm going to give you the equation of a line, and I'm going to ask you for a perpendicular line that goes to a certain point, let's say. And then the payoff will be to graph it and make sure they're really perpendicular. So let's figure that out. Okay. So this is the last thing we'll do, and that is find the equation of the line perpendicular to this line. And this line I'll put in general form just to make things interesting here. So let's do 2x minus 3y equals 6. So that's my initial line. So find the equation of the line perpendicular to that line that also passes through this point. And let me come up with a good point here. How about negative 2, comma 1? Okay? First of all, is this point on that line? Let's check. Make sure that it is not. It doesn't matter one way or the other, but negative 4 and then minus 3 is negative 7. So no, that point is not on that line right there. So how do we do this? Now, that's not in general form also. I moved the 6 over right away, I guess. But the first thing you've got to do on this is find out the slope. M1 is what? So 2x minus 3y equals 6. Let's solve for y. Solve for y. If you solve for y, you quickly realize what the slope really is. Y equals 2/3 x minus 2. And this is the only thing I really care about. There's my slope. So think about the reciprocal and negative to get your perpendicular. M2 is the negative reciprocal. It's negative that and also upside down. Now you don't have to write this. Why don't you just turn this upside down and add a minus sign? That's my new slope. Now think about this, guys. Not only did we get the slope of the old line, got it, it was 2/3, we got the slope of the new perpendicular line. That's the one I'm really interested in. And read what we have here. We have a slope on the new line, and doesn't the new line possess this point? And which form would you use given a point and given a slope? Well, we have a name for that. It's called point-slope form. So here comes the new line. The new perpendicular line, I'll use that symbol for perpendicular. Y minus y1 is m times x minus x1. We better go get our x1, y1. Here's the point that's supposedly on this new line. So it's y minus 1, and it's x minus 2. And what was that slope of our brand new perpendicular line? It certainly wasn't the slope of the original line. It was negative 3/2. So here it is, the equation of our new perpendicular line. So it's negative 3/2, it's x plus 2. And I really prefer finishing up by distributing here. So it's y minus 1. We get negative 3/2 x. Let's distribute some more. And we get negative 3 because the 2's cancel here. We add 1. And we get y equals negative 3/2 x minus 2. There's my new line. And let's not forget what the old line is. The old line is right here, but I went ahead and solved for the old line in slope-intercept form. So let's write that down. Well, something happened here that I wasn't expecting. They both have the same y-intercept. That does not happen all the time. So, well, what I am going to do for you is graph these two lines, and I'm going to make darn sure that they're perpendicular, and also I'm going to make sure that the new line has the point that was specified, negative 2, comma 1. Now, if you really want to do this right, we should use graph paper. So let's graph the new and the old. Starting with the new, the y-intercept is negative 2. The rise over run is right here. That says run over 2 units and fall by 3 units and place a point. Do it again. Run over by 2 units and fall by 3 units. Place a point. And go ahead and connect the dots. This is our new line, by the way. Almost. Got to line everything up best that you can. Okay, I'll label it. That's my new line. Now the old line just happens to share the same y-intercept, but the instructions are to run over 1, 2, 3 units and to rise by 1, 2 units, place a point. Run over 1, 2, 3 units and rise by 2 units, place a point. Run over 1, 2, 3 units. You can do that as many times as you like. Connect the dots. So let's connect these very carefully. Now let's see if this paid off, guys. Old line, new line. Now, number one, are these lines perpendicular? There's certainly one good way to find out, and that's take this and rotate it. And you'll notice something. This line's horizontal, and that line's vertical. 90-degree angle right in the middle. So definitely these lines are perpendicular. But wait, the new line better have -2, 1 on it. Let's go hunting. Well, look at that. Right there, we zoom in on it, we find on the new line the point -2, 1, just like we're supposed to. So it did work. It's very successful. So I want you to practice. I want you to practice looking at equations of lines, getting the different forms of the equation, and most importantly, finding parallel and perpendicular. Parallel, a little bit easier, just set the slopes equal. Perpendicular, you can see, don't forget, M2 is -1 over M1. By the way, we didn't talk about this, but what is the slope of a perfectly horizontal line like this? There we go. Slope is 0. You can run as much as you want. You don't get any rise. What is the slope of a perfectly vertical line like this? Well, there's actually no run. It's all rise. So we're rising on top divided by 0 because there's no run on the bottom. That's infinity or undefined. Vertical slope is undefined. Thanks for your patience and your attention. I know the videos are running a little bit long, but we're really learning a lot, and I'll see you in the next video.